In this video, we're going to talk about how to derive the equation for the electric field of an infinite sheet of charge, and we're also going to actually derive it. So first, let's look at this sheet of charge over here. Let's pretend that it's infinite. So first, we're going to define the surface charge density of this infinite sheet. We can define that as sigma equals Q over A being the area. Now this can all be rearranged to Q equals sigma times A. So to actually derive the equation, we're going to be using Gauss's law. First, let's draw a Gaussian cylinder coming out of both sides of the infinite sheet. So it would look something like this. And now this is valid for Gauss's law because E dot n in Gauss's law is easy to evaluate at every point. So let's write out Gauss's law. So E dot n dA equals Q over epsilon naught, Q enclosed. So let's think about this electric field. So the electric field would be coming out of the plate on both sides like this. Now, if we think about the Gaussian cylinder, we're going to have on the end caps, the end vector is like this, and on the curved cylinder, the end vector is perpendicular. So that means that the dot product can be evaluated at both points easily. So now let's continue writing out this equation. So we have E dot n dA for the curved surface plus E dot n dA for the end caps, and this equals Q enclosed divided by epsilon naught. Now, for the curved surface, there's actually no electric field flowing through there because the electric field is going to be perpendicular. It goes like this, out of the plate from both sides. So this whole term is going to be equal to 0. So we can rewrite this as E dot n dA for the end caps equals Q enclosed over epsilon naught. So now, because we have two end caps, this term is going to be 2. So 2 of these terms. So let's write that as 2 times E dot n dA and caps equals Q enclosed over epsilon naught. Now let's think about what this integral is going to be. Now, because the electric field and the end vector are parallel, that this can just be written as EA. E times A equals Q enclosed over epsilon naught. So now this is where we bring in the surface charge density into the equation. So we have I forgot to write the 2's here. 2 times E times A. A is going to be the surface area of the end caps of the cylinder. So this can be written as pi r squared equals Q enclosed over epsilon naught. So here is where we bring in the surface charge density. Q is equal to sigma times A. So sigma being the surface charge density times A, which is the area of the enclosed charge. So that's going to be a circle, just like the end caps, with the same radius as the end caps because it's a cylinder. So pi r squared. Notice that these two terms will cancel out. So this becomes 2e equals sigma over epsilon naught, which can be written as electric field equals sigma over 2 epsilon naught. This is the final answer.